Hello, Collegiate Cyber Defense Competition competitors. I'm Jim Boardman from the Palo Alto Network Cybersecurity Academy, and this is the final video in a three-part video series covering the CCDC threat environment and firewall best practices. In video number 1, I talked about the threat environment that you could see at CCDC competitions. In video number 2, I talked about the cyber attack lifecycle and about best practice number 1. In this video, I'm going to talk about best practice number 2, 3, and 4, starting with reduced attack surface area. And then finally, I'm going to talk about what's next. How can your team better prepare for the CCDC competitions? Now that I've made a determination of what applications I'm going to allow into my network and what applications I'm going to allow out of my network, then the next step is I want to configure my firewall to only allow those applications that will basically keep my scored services up and running, because those are the only applications I should allow out or in. So that is called whitelisting of the applications. Now, it is possible you could have custom applications running inside your network. I don't know how possible this is in a CCDC competition, but you might have those as well, so you may want to identify that. So you might be asking, what is an application? An application is anything that can be detected, monitored, and blocked. So the firewall, what it does is it looks inside every packet. It goes all the way up to the application layer, and the amazing part about it, and this is kind of the heart of next generation firewalls when they first came out, is being able to do this capability of looking inside the application layer of every packet and make a determination as to what that application is. And the way the firewall does this is through a feature which is called App ID. And the firewall implements App ID through application signatures. And these signatures are downloaded by default via the management interface of the firewall appliance on a weekly basis. And what the firewall does is, as packets stream across it, it will look for content in the application layer, and it will match that content to an application ID, or attempt to match it to an application ID, to make a determination as to what the application is. There are approximately 3,000 application signatures. So an application could be, there's lots of web applications, as you could imagine. Facebook is its own application. Google is its own application. There's lots of software as a service, cloud applications, Microsoft 365, Google. So the idea of it is to use these applications, put them into your security policy. So when you add the application to the security policy, then only those applications in the security policy are going to be allowed. So the other thing that you see, the other option you see here, is dynamic address lists, and these would be traditionally used for blocking traffic. I don't know how effective blocking traffic is in a CCDC competition, because of the fact that the red team can change IP address. They can camouflage IP addresses, and then as soon as you start blocking an IP address, it becomes legitimate traffic, customer traffic trying to get into your website or so forth. So, but you can, the cool things about dynamic address lists in our firewall appliance is the fact that any changes to that list will be automatically incorporated into security policy, so you don't have to continually recommit it. And you can also reduce your attack surface area by configuring your firewall appliance to only allow the most secure protocol settings using your decryption policy. By setting the versions of TLS you want to use. And you can use the decryption policy to block bad certificates or expired certificates. Now let's talk about security policies. And security policies are nothing more than a list of rules. So what happens is that when a packet comes into the firewall, it starts with the first rule. Rule order is important. So if your first rule was to allow everything, and your second rule was to block telnet, then everything's going to be allowed, right? So rule order is important. So, but and all firewalls pretty much operate the same way. That's what I always tell my students. And normally the action that you would have would be either to allow or to deny in a firewall policy. And if there's not a match in the first rule, then a firewall will continue to go down a list of rules. And if no match is found, then what will happen is it'll reach the default policy. The default policy for most firewalls is to block everything except that which is explicitly allowed. So in our firewall is zone based, so interfaces have to be assigned to zones in order to pass traffic, to filter traffic through the firewall. So if you had the example here of, let's say, your external zone and then your internal zone, okay, so by default, traffic going out of your firewall and traffic coming into your firewall is going to be blocked. So that's not going to be allowed unless you have a rule that allows that traffic. Traffic within the same zone, the default policy for traffic within the same zone is to allow that traffic. So again, to recap, between two different zones, the default policy is to deny the traffic. Within the same zone, the firewall's default policy is to allow that traffic. So you got to keep this in mind as you craft your security policies. I can't really stress how important it is to know more about what's going out of your network, even more so than knowing what's coming into your network. I mean, the idea of it is I think we're still into this legacy mode of thinking, and maybe at least a lot of the textbooks are, and even the CISSP certification to a certain extent. And it's an outdated mode, and that mode is, right, I just have a shield, and all I have to do is block everything that's bad coming into my network, and I'm okay. But you always want to pay attention to what's going out, because we know malware, like we discussed before, loves the phone home. So maybe I can't block the delivery of the malware, but I can certainly disrupt the malware by disrupting it going back and phoning home. So I should know that both from a host level and also from a network level, like you would have in a firewall. So that's very important. The other thing which I can do with a security policy, and to kind of narrow the gap, right, to reduce that attack surface area. So you see here I have examples of services that could be running on the inside of your network. These are scored services, SMTP, it could be FTP, whatever. But what I could do is when I set up my security policy, I could say, I only want you to allow this traffic, only allow this traffic to a particular IP address, right? So I'm only going to allow SQL to this server. I don't want it going to, I don't want it to allow it, from the outside to the external to my inside. It's a scored service. I should only have it running on one server, and then that's the only server I should allow that protocol, the application, to come through. And so I can do that. I can narrow that footprint even further by aligning an IP address to it. I don't want FTP going to my Windows client from the outside network. It's not necessary to keep my scored services up. I should only have it running to my FTP server, wherever that would be, whether it's in my clouds, as you see up here, or whether it's in my bare metal machines, as you see down here. So that's also a way in which I can reduce the attack surface area. It's also important to realize that security policies are stateful in the Palo Alto Networks firewall appliance. And what does that mean? Well, that means that if I have an inbound security policy allowing traffic to my scored services, the return traffic will be allowed automatically by default. I don't have to set up or configure a separate security policy to allow the return traffic. So that's what we mean by stateful. Okay, so let's move on to best practice number 3. And best practice number 3 is protecting against known attacks. So here we are. These are known attacks. And I do that again using a security policy. And then what I do is I make sure I have security profiles. I assign security profiles to that security policy. So here you can see a representation of a security policy in the web UI. These are the security profiles. So I have several profiles here. These are the ones that would be defend against known attacks, antivirus, anti-spyware, vulnerability protection, URL filtering. And as you notice here, I also have the ability to do file blocking. Now, some files are okay, other files aren't. I just throw that in there that this would be a way in which perhaps maybe I don't want to download executables to Windows clients or to scored services. So that would be another way in which I could defend against known attacks. So I dig deep into my CCDC Moodle course, and there where I could find content ID information, or in the content ID module I can learn all about the security profiles. The firewall also does provide denial of service protection, as you see here. So I can do that through 2 ways. I can protect the external interface of the firewall by setting up a zone protection profile and assigning that to my external zone. So I would assign this to a zone. So this would be the external interface. So the other one is if I have, let's say, servers running on the inside of my network or in my DMZ zone, I can use a DOS policy profile and a policy, and a DOS policy to provide denial of service protection. Now I will say be very, very careful when you're using a zone protection profile or denial of service profiles, because you could make it so restrictive that you're not allowing anything to get to your scored services, so your scored services are going to be down. As a matter of fact, when I was teaching at Alfred State, I had a team that's what the person did that was managing the firewall. So for quite a while all the services were down until he figured out that it was because of a very restrictive denial of service zone protection profile that he assigned to the external interface of the firewall. There's a whole entire module on URL filtering, so I encourage you to go into that. That's also very useful in protecting known attacks. So when we discuss the security profiles, again, you can think of security profiles, because I'm assigning those to security policies. You can think of them like additional rules that I'm adding to the security policy. So the ones, the big 4 are the anti-spyware profile, or we'll start with antivirus. Antivirus, anti-spyware, vulnerability, and URL. We think of URL profile, that's really URL category. So we categorize all web URLs As you can imagine, lots of them are created all the time, and we actually categorize those. So it's kind of interesting when I go around the world and I teach instructors around the world. One of the things which I ask them to do is enter a URL into our categorization. You can do this online, and see if it categorizes it correctly. And normally I ask them to pick one that's not known throughout the whole entire world, that's kind of generic to their country. And I don't think there's ever been a case where where the firewall has not, our URL category service has not correctly identified it. So it is very good, and it is very current. So if you look at it, all these security profiles, they rely on signatures, and or at least the big three, the first three of them rely on signatures. And as we discussed before, those signatures are downloaded through the web, through the management interface, and that management interface gets it from our update server, right? Now the antivirus is updated each day. So when you enter the competition, if it's a 2-day competition, you'd want to make sure that you get the latest updates on the second day after the first day. Anti-spyware and vulnerability, those are updated on a weekly basis. So that would be basically you're covered there. You wouldn't have to worry about it. URL category, that's a little bit different. URL categories, this is stored in, it's a seed database, but it starts out as a seed database, but it's stored in cache memory. So as you can imagine, is like you said, lots of updates on URL categories, lots of websites being created all the time. So the firewall, our URL categorization service, any changes are loaded in cache. So where that becomes kind of important to have an understanding of is that if you, for some particular reason, if your connection to the update server, if you can't not connect it to it, then the cache will expire. URL category cache will expire at some point. And the other aspect of it is that if the URL that you're accessing isn't in the cache memory of the firewall, it will then consult the update server. If it can't consult the update server, then it will categorize it as being unknown, and that could be inaccurate. It might be something that is known. So that's another thing that you got to keep in mind. Where URL categories, where it can become helpful, is in preventing DNS beacon attacks. So a DNS beacon attack is when the red team goes out and creates or registers a domain. And you can do this. They do this right during the competition. And they can register a domain and they can call it something like bad.com. So what happens is that this happens pretty quickly. So our category service may not pick this up as being a malware domain. Wildfire might take a little bit of time for it to look at the sample and make a determination. So there may be a time frame in which case when, like we discussed before, malware, once it loads on a client, as I say, like in this example, once it does that, it tries to phone home. Well, it does basically two things. So it first it goes to the DNS server of this new domain that the red team has set up, and it tries to get an IP address, right? Does a query. Once it does the query, then it tries to connect. tries to connect to the Windows client tries to connect to the command and control server and gets the instructions or gets more malware to download. So the firewall can be useful in preventing these type of connections, but there may be a period of time where the domain's not recognized as being a malware domain, or even the server's not being recognized, command and control, as being having a URL category of malware. So there is that moment, there is that opportunity where this connection could be allowed. Now, one way in which you can prevent that is if you use the unknown category here in the URL. So if I use unknown as, if I configure my URL profile to block connections to unknown URLs, then this would prevent or disrupt the attack, I guess I would say. So you could disrupt the attack by doing that. Okay, the last best practice is provide protection against unknown attacks. So that's kind of key. Again, you do that using our security policy, and in this case you want to assign a wildfire analysis profile to that security policy. Again, if you don't assign a security profile to a security policy, you're not going to be able to block known attacks, and you're not going to be able to block unknown attacks. So that's the key. You got to have the security policy, as you see here, and then I got to have the security profile assigned to that security policy. So when you do this, then Wildfire will analyze unknown documents, unknown anything that it hasn't seen before. So let's go take a look at how that works. And again, before we go there, further our discussion, you can find more information about Wildfire in the Wildfire module, which is in the CCDC Moodle course. Okay, so here we have back to the network, and we have the crafty little red. And they are in the weaponization phase, and they have crafted a Word document. And in that Word document there is a macro. And they've given this to the white team, and the white team says download this document to get the instructions to complete this inject. So you know that you got to complete all the injects, you know you got a certain bit of time, so you just download it. So now if this is the first time the firewall has seen this Word document with a macro, what it will do is it will make a copy of it. It will send the copy over to the management interface, and then the management interface will send that copy to the Wildfire sandbox. And the Wildfire will take the sample and will make a determination. And Wildfire will do two things. The sandbox will do two things. It will send down to the firewall. It will send a report saying, and let's say in this case it is malware because the red team crafted it. And then once the sandbox determines that this is malware, it will not only just send the report down, it will actually generate a signature to block this malware, block this document from being downloaded. Now you want to employ that signature, and the way you do that is you want to make sure your antivirus security profile that's assigned to your security policy, you want to make sure that that antivirus is using that antivirus security profile is using wildfire signatures. Now this isn't configured by default, so you have to make sure you do this in order to take full advantage of the signatures you're getting. And it takes 5 minutes. 5 minutes after it makes a determination that it's malware, Wildfire will generate a signature within 5 minutes. So a couple things here. So as you notice, we talked about a copy is sent up. So what happens to the original? Well, the original is actually allowed to go through the firewall and to the Windows client in this case, because it's a Word document. So you want to make sure that in this case you haven't blocked the attack. Now if there's some time, it's possible that, let's say, the team number 2 that's in the competition, they haven't gotten to this inject yet, and they download it, and there's enough lapse time. And if there's enough lapse time, then if they've got their firewall configured and they're using the wildfire signatures, then it could be blocked. The same thing for any malware, and this is the way it works in a worldwide situation. And this is what's kind of cool about a community sandbox, right? So anybody that discovers malware anywhere in the world, or anybody encounters malware using our firewall appliance, and if it's new malware, in other words, there's not any signatures for, it's not known, so there's no known signatures for it, then any signatures that are generated by Wildfire are going to be shared throughout the entire world. So you can, the first person that gets it, obviously, they have some problems. They got to make sure they go in and remediate their Windows client in this example. But everybody else, subsequent, if there's enough time that's lapsed, at 5 minutes after it's discovered that it's malware, everybody else is going to have that signature, and everybody else is going to be blocking this traffic. So the key is, I just want to make sure that you look at your reports for Wildfire, because that's where you're going to see malware was downloaded by this Windows client, and then you're going to go in and then you're going to know, hey, there's something bad about this Windows client. I need to clean it up. So that's how Wildfire works. Okay, so you might be wondering what's next and what should be my first steps when I enter the room. So let's talk about the first steps when you enter the room. But before we do that, I just want to say this: what you see here on the right, this is our lab pod, or this is a lab pod that we developed, and NetLab is NDG, Network Development Group, is hosting this on their online NetLab Plus appliance, and they've graciously and generously are allowing teams that compete at both the qualifying competitions and the regional on-site competitions to use this to practice on. And you can, and the good news about this is, like I said in the beginning, is that if you can configure our virtual firewall appliance and you can configure the hardware firewall appliance, the commands are identical, the web UI is identical. But with this pod, there's structured labs, but you can practice anything you want in this lab. You can change any of the configurations. Like as an example, you could come in and you could add insecure configurations to the firewall appliance and then practice securing it. You could practice, configuring all the best practice as fast as possible. So there's lots of things you can do. You don't have to follow the script of the labs. You can follow the scripts of the labs too. But you're pretty much free to do everything you want to do on this. So the reason why is because after your scheduled time is over, it goes back to the master snapshot. So anything you've done is going to be corrected. So don't worry about that. So one of the first things that you want to do is we talked about this, is you want to make sure you secure that management interface. So here's the management interface in this diagram. And so the way you do that is using a console port. And you can access the console port from the hardware firewall appliance by connecting serially to it, and you can access the console port via the hypervisor on our virtual firewall appliance. So the console port is where you're going to enter command lines, and this, I recommend you practice this because you want to make sure that that management interface is secure. That's the best way to get the updates, easiest way. And so what first thing you should do using a command line is you want to change the password. And sometimes I think that's really a lot of what the CCDC competition is. It makes changing passwords very exciting because if you don't change them, the red team's going to get into your box. So that's key number one. So after you've changed your password, you want to restrict who can access the management interface, and you can do that using a permitted IP configuration, kind of like an access control list. So I could configure it so only my inside client has access to that management interface using permitted IP. Third thing is you want to make sure that you don't have any services on there that are insecure. So you can configure the firewall appliance to use Telnet, or the management interface I should say, on the firewall appliance to use Telnet. Now why you'd want to do that, I don't know, but when you enter the room, maybe it's on there, maybe Telnet's on there, maybe Telnet's on there, so maybe HTTP's on there, maybe SNMP's on there. These are all things that I probably don't want to have. I want to get rid of those. And I should spell Telnet a little bit better. I want to get rid of those services. The only services I should have are HTTPS, SSH, and maybe ping, right? So I know it's up and working. So other than that, I want to make sure everything else is eliminated. And the fourth one is if I have any admin users that have been created, before I entered my competition area that aren't needed, I'd want to delete those admin users, and I'd want to do that from the command line. So all these things I want to practice, and I want to do those from the command line. So once you've practiced on the lab, the other thing is you want to dig deep into the CCDC Moodle. This will be up and running starting in 1 November, along with the practice pods that are on the online NetLab appliance. And you want to contact your regional direct to get your authentication tokens. The one last bit of advice I want to give you, and this is a non-technical advice, and I would say that this advice is also good in the workplace too, and it will lead to great success to anybody that employs this advice. And that is, it's nice to be nice. And this was scientifically proven by Google. Google actually did a study to find out. They were looking at team dynamics. What makes one team better than another team? What makes one team produce more output or reach their goals faster, quicker, smarter than other teams? And what they found is it wasn't really technical competency that drove this. It was really the team dynamics. That is, whether the teammates, the team members respected each other, whether they got along well together, was really, really huge, much even bigger than technical competency as far as for team production. So, and I used to tell my teams the same thing. You got to talk to each other. You got to be nice to each other. You don't want to blame each other. If you make mistakes, everybody's going to make mistakes in a competition. You don't want to get into the blame game. And I've also seen traveling around and doing lots of CCDC competitions and observing team members in rooms. The teams that are talking to each other in a nice way, those teams always do better at the end of the competition. So I'd say this is even more important than technical competency. Although technical competency is important, but if you can add this nice vector to it, then you're going to do well in the competition. And with that, I want to wish you the best of luck as you compete at the qualifying competitions for CCDC, at the regional competition for CCDC, and the national CCDC competition. I hope to see you at the regionals, on-site regionals, or at the national CCDC competition. But regardless of whether you make it to past the qualifying competition, or if you don't make it to the nationals, I'm going to tell you it's going to be a very good learning experience for you, and it's something that you can put on your resume and something that businesses are looking for, especially that team dynamics. Companies are really, really interested in that team dynamics. So remember, nice to be nice.